into it.
Excellent.
Let's go for it. So plan is to create some cool looking snowflakes using an algorithm called diffusion-limited aggregation. I've got an incredibly rudimentary diagram going here. But here's the basic idea. You can imagine over here at the origin, we're going to slowly grow a snowflake. And it's going to grow like this way. We're
Is
growing
this like a slice of the circle?
Yeah, it's like one slice, and then this will be like repeated 6 times.
Sure.
So yeah, this kind of
right,
forms like
'cause
one
snowflakes
segment.
have like a six-sided crystal sort of thing. Right, gotcha.
So it's going to grow from here, and the way we're going to do it is we're going to spawn a particle somewhere on this blue line, and then we're going to use brownian or just motion or like a random walk, just kind of move the particle, and it will like jiggle around, and then it will go to here. And if it gets like past the origin, then it will stop, and it will become part of the cluster. Or if it gets too close, like if it touches one of the existing parts of the cluster, it'll also stop. So it's very simple. And it will kind of grow out like kind of dendritic tendrils, and it should kind of create like a cool structure. And then we'll just kind
What happens if it touches the edges?
These edges here, it'll just kind of get pushed along. So it'll be prevented from going outside. So we'll have to do a little bit of trig to do that. But it should be set. Alright. So plan is to use TypeScript and canvases and just do something kind of nice. Gonna set up a Vite project. Fingers crossed.
And why are you using Vite, Ewan?
Vite is just nice and fast, easy use. Remove existing files. Oh no, probably not. Oh no. Yes, do remove them. Alright, we want vanilla with TypeScript. Then we want to install deps properly. Here we go. Let's see what that looks like if we run that. So I should be able to bring this up here. There we go. This is kind of like the basic program. Now let's just remove basically everything. That should be good enough. So it should be like nothing. Yeah, cool. And we kind of don't need most of this. Although honestly, dark mode.
You just put like color scheme light dark on them.
Yeah, honestly, no, but like it's kind of nice though.
HTML.
We kind of don't need that either. Whoops. So it's going to put a JavaScript Canvas and give it just like a really boring ID. And we will configure its width and height from inside the code. Let's confirm that that's there.
Does it even need an ID?
Yeah, it probably doesn't really need an ID, but it's more flexible.
Okay.
So we'll get that from the document. So let's get canvas. And then this exclamation mark here is just telling TypeScript like it's definitely there. And we'll tell it that it is a HTML canvas element. Cool.
Oh, I guess because it could possibly be not there, huh?
Yeah, and then we'll give it a reasonable width. We'll make it a square, I guess. I'm thinking like 1,000 by 1,000. And we'll want to know these. So we'll store these for later. Here we go.
Well, if they're on the canvas, then you can just grab them out of the canvas again.
That's true. It's more convenient this way.
Okay.
And we'll get the context out of the canvas so we can use it to draw. And then we'll set up like a kind of opportunity for us to draw. And then we'll make it so that this draw method asks for it to be drawn again. And then we'll start a program by requesting that it runs draw. So if I just as a test, we can put in like, let's do fill a rectangle. See what that does.
That is a rectangle.
That looks right. So you can see I've made it way too big because it's like the whole page.
It is.
Let's
You can resize it in CSS.
Yeah. All right. We'll just do it simple there. There's the canvas. All right. And then I don't know what they're doing here exactly, but we'll just. What have they done? The defaults. We'll just change margin 0 to margin auto. You know what? Just gonna try and get everything into the middle. Cool. And just for demonstration, we'll make the canvas.
100 min height on the body as well.
Which one?
Min height on the body. Oh, and
that's alright for
just
now.
get rid
That's
of the
good
margin
now.
as well. Okay.
True, a good one actually. Cool. Alright. So we're drawing a rectangle, very dull so far.
It's a beautiful snowflake. I reckon it's done.
You can see the six-sided symmetry.
Mm.
Cool. So I guess what we need now is we need a way to keep track of a particle. It'll like travel along. And what would be nice is once it hits the middle. So we'll call like, say the segment is like this or something. So I guess we'll start off by defining what the angle is defined by that segment. Like this angle. Although if this is forming a full circle. Let's just define it arbitrarily for now. Something like this.
Not even using tau?
I know, right? I thought about it.
Do math. Tau divided by 12.
True, true. Alright, so we'll keep track of the current particle. And we'll make this like a vector-ish thing. So we'll say it starts at like the full width and then half the height. So it's just like over here. And then we'll move it left. So let's start by like draw where particle is. I'm gonna do do you reckon a circle? Circles are like a kind of a pain. No, we don't want that. Let's just make this. There we go. Ooh, do I remember this? Okay, so this will be particle 0, particle 1 to draw it where the particle is, and then the radius will be. No, wait. We'll just make the radius like 1, and then that'll be 0 to math.py times 2. Cool, that should work, and then we'll fill that in. Cool, so it should just have like a little dot. Yeah, you can see it's there, it's tiny.
Oh my goodness, it is very small.
Okay, so we'll draw where the particle is, and then we'll just do that like brownian motion bit. So we'll say, like, remove the X position slowly to the left, and then the Y will just make it random. So it'll be between 0 and 1, and then we'll take that, add 1, divide that by... wait, no, that's not right. We want -1 to 1. What?
You lapping?
No, we just want this to be... So that's now 0 to 2, and then if we'll subtract the 1, that should give -1 to 1. There we go, it's already doing it.
Oh, damn, okay.
Nice.
This is going to be like trend towards like a straight line there. Like, how are you going to make it?
Well, we just got to kind of exaggerate that motion a little bit. Let's make that a variable. I don't know what the like noise.
Why is it called brownian motion?
It's named after a guy called Brown, and he was studying like cells and the way things move in water and stuff, and he kind of found that they move like effectively randomly.
Right.
So I'll just take this whole thing and just multiply that by noise. Yeah, so this is just getting a random number between -1 and 1. So I'm just multiplying that by noise. So it's -3 to 3 now, which just means it'll be a lot more dramatic. That's probably a little extreme. I'm starting to feel like I may have done that wrong.
Yeah.
Or I'm getting really unlucky.
No. It's literally
Oh yeah, wait a minute. That's more like what I was imagining. Cool. And then when it gets to the middle, we want it to stop. And right now, it's drawing what looks like a line, but that's just because we're not clearing the screen at all. Alright. So we'll clear the screen every time. Clear the whole rectangle from 0, 0 to width height. And now you can see it's just like a little fly. There he goes. Cool. Brownian motion. And then, what do we want to do next? We've kind of just got to keep track of when it hits the left. So, particle joined cluster.
I think you should get some wings next.
Yeah?
Yeah.
It's tempting. So if this happens, we want to stop this particle, add it to a list that will form like our cluster. So let's establish that cluster. We'll just make it an array. I'm gonna just, for fancy, you know what? It's not worth it. So when this happens, we'll remember how to do that. We'll push our particle onto the cluster and then reset our particle. So we'll put it back. Where did I do that? We'll just kind of do this. Whoops. So it should just be that. And then when we draw the particle, instead of drawing the particle, we'll just draw, well, actually we'll leave that for now, but we also just want to draw the cluster. So for let particle, and you know what? Cluster dot for each particle in the cluster. Variable cluster, yeah, I knew it would do this. So we'll say that a particle is a pair of a number and a number, and we'll describe this. So say this particle is a particle. This cluster is just a list of particles. Cool. It was just complaining about types. Classic TypeScript stuff.
Classic TypeScript.
I don't know exactly why I chose to make it TypeScript. Let's see if it does it.
Why
Oh,
not?
hype. Here we go.
Wow.
It's going to take a while before anything exciting happens, not going to lie. And then, yeah, actually it's going to take ages. Wait, let's make the canvas a bit smaller. Let's go like 100s. And then, yeah, like you were saying before, we'll scale up a bit. Ooh, do you know how to do like the denoising thing? Like when you...
Yeah, I think, I mean...
Ooh. Let's just demo how you do software stuff. I definitely have done this. Pixel smoothing.
I don't think you're on the right page.
Nah, this doesn't feel right. Yeah, this looks like the right. Set rendering hint. No, no. Scaled image view.
No.
Oof.
No, you gotta set
It's like sharp or something, right?
You set something to pixelated.
Here
The
we go.
CSS
Context
stuff.
image smoothing enabled. There we go.
I guess also that.
And hopefully.
Yeah, but that won't fix the So on the
like
CSS
rendering.
Hmm.
Here we go.
Image
Hey,
rendering.
got it.
There you go.
Just totally remembered that. Came to me all of a sudden. Cool. It still
But
goes a
like-
bit weird because it's doing some some filtering stuff still. But that's right. You can see kind of what we want to happen. So we want it to be that when it touches an existing one, it should be sitting like outside of it. It shouldn't be sitting inside of it.
Yeah.
And maybe we can help this along a bit by not assuming that they're the size 1. So I was doing these particles as being like just like an array, but we might want it to have a bit more information. So instead, let's say it has an X position and a Y position and a radius. Let's assume they're all 2. Gonna have to change all of these. Doing some early refactoring. Love to see it. Oh yeah, of course. Okay. Now locked myself into that. You know what? We won't worry about radius for now. I'll just assume they're all the same. But we might want to keep track of color at some point. I think could be fun. So, so we'll do that, and then we'll say if the particle's X, blah 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 blah. This new particle. So we'll just reset the particle. And you can see we're repeating that process, but we'll
Well, give you the idea to look into this.
So there was a really good video by the Coding Train on YouTube where he did like a simple version of this and then kind of said like go make something cool. And so I'm thinking of extending it a bit, creating it in Canvas, doing some colors. It'd be cool to practice this and then do it in 3D as well. It also just looks really cool and it's fairly simple in terms of like practically putting it together. Okay, so we should be back where we were. Cool. But let's assume that all of their radii slightly more. And we should be able to increase just this number. Oh, whoops, wrong one. It's both that one and that one. Cool. And then the particle joined the cluster if this, or if it touched the existing cluster. So let's just kind of put that in a function. I'm going to call it is touching cluster. We'll tell TypeScript the particle we give it will be a particle. Cool. And this will return a boolean. Regretting doing this in TypeScript already. But yeah, so the particle joined the cluster, either if it's like off the screen basically, or if it's touching the existing cluster. Cool. And yes, I'm a snowflake, confirmed. I'm generating myself. So probably easiest way to do this is just loop through the cluster and check for each one. We'll do cluster.sum.
Oh, it's little emojis.
We'll just immediately return that. Cool, so I check for if some other cluster in the particle is touching it, which just means that for circle collision, it's really easy, because if I draw it up, whoops, not like that.
Beautiful circle.
Thank you, thank you. Oops, if we have this circle and this circle, we can just measure their distances.
Not to scale.
Not to scale. We can measure their distances, and like if the distance is smaller than the radius, like the radius added, then we're touching. Easy. So for now, I'm just assuming the particle radius, but we'll start by getting the distance between them. So I'm thinking it might be nice to have a method for this as well. So we'll just quickly put that together. So we'll talk about getting a distance between 2 points. And those points should have x and y's. And
well, those points will be
actually,
particles.
Yeah, may as well make them particles, right?
Yeah, I don't know what else you'd be getting distances for.
Good point. Let's just make this immediately return. So it will be the square root of the x difference squared. And in JavaScript, unfortunately, there's no nice way to do that, so we do this. And then we get the y difference.
Yeah, in Python, you can use like 2 stars, right?
Yeah, it's really nice. You can just go like this. JavaScript's not really got an equivalent. You can do some hacks with like bitwise stuff, but not ideal. So if the distance between particle and other particle is less than 2 times the particle radius. And we can change that to use custom radiuses as well.
Yeah.
Okay.
They don't seem to be.
I'm gonna go with that's not working.
Yeah.
Cluster.sum, other particle. Let's just make it less strict for a second.
Are you returning bit? Oh, wait.
Oh, no, you're right. I'm absolutely not.
Yeah, okay.
Thank you. Good catch. Please. Please. Oh, it's more like it.
That's working.
Nice.
Wow.
We're generating something. Is it a snowflake? Eventually. Eventually.
Very interesting. You have generated something.
Technically, yeah. All right, let's make this a bit bigger again. Now, it's kind of fun to watch them move over, and we'll probably keep this a little bit, but we can speed it up a lot by just looping until it touches.
Yeah.
Which means it'll just grow like way faster. So let's do that. While not, and we probably want to merge. It's all right. While not particle.xless, I could copy it. Cool. And then we'll just, that will happen afterwards. Cool, let's fix these comments up. Brownian motion until touching. Cool. Much faster. Very hype. It's kind of like coral.
It does look kind of lightning-y.
Lightning-y. Well, it's funny you say that. So I was reading the Wikipedia page. I know, this is the extent of my research. I did technically open the paper, but I read the abstract. I think it's this one. Yeah, you can see the dielectric breakdown.
Yeah.
So, you know,
those
it's
Lichtenberg figures.
And like diffusion is just where you have particles densely like packed together and they want to like spread out. And I don't know, I'm not a physicist, but that could apply to lightning.
I mean, lightning travels through the atoms in the air, like the
True, yeah.
like the ions and everything, right? I don't know enough science to say this on a stream.
Just gonna temporarily get rid of that too.
Well, it travels through the points of lowest resist.
Right, yeah.
Yeah.
So I'm thinking as well, like kind of as I'm doing this, but if there's cool ways we could color it, I'm thinking it would be fun to start with one color and then shift to another gradient as we add particles. And to see, in that way you'll kind of see where it grows in what order.
Yeah.
Setting that up
That'd be
might be a
cool.
little involved, but I think the easiest way to do it would be to keep track of which index each particle is. So when we add it, we'll kind of increment an index on it. And that way we can kind of just color it based on that index.
That makes sense.
Oops, I literally called it index. Also, because it's getting frustrating redoing that, I'm just gonna do... it's fine. It's not a big deal. Cool. So the index will just be the length of the cluster. And that way, over here, also, we don't need to draw with the particles anymore, because we're just immediately adding it.
True.
Over here, we'll set the color. Okay, this is going to be slightly involved. Maybe we'll do, I don't know, 50%. And we'll get it.
Your SL part?
Yes. So I'm thinking...
Probably don't need A.
Yeah, good point, good point. Why don't we do that? And then we'll just...
Normally like 50%, 100%. And then the H will go at the start.
We'll do like... very saturated. True, we could just go through hues. I was thinking it could be like lighter as it goes on, but hues might be more visible, to be honest.
I mean, hues will definitely be more visible, but it won't be as aesthetic, probably.
What are we going out of?
I don't know, actually.
It's like assume 200, and then we can make it wrap
also,
around.
it's not a percentage.
Yeah, no, I'm getting there, we're getting there.
Okay.
And then we'll just... I don't know what it'll do if you go out of 100, but something bad. Let's see if that's...
Well, it goes up to 360.
200 might be very... 360. Oh, good point. Oh wait, it's not percent as well, is it?
No, that's what I said. Yeah.
Oh, that's what you meant. I thought you meant like, it's not a percent yet.
No. It doesn't need to be a percent.
5?
360.
360, you literally said that.
It's not the
And then the mod 100's wrong. Oh my goodness.
My goodness.
Oh goodness me. Alright. Bring back the paren. Bring back the paren. This is absolutely not working.
Clearly not working.
It's clearly not working. Alright, let's try. Well,
it's because you're doing it after you begin the path, probably.
Oh, I think it's before you fill, isn't it?
Is it?
I think it's just before you
you're
fill.
totally right. It is before you fill.
It's probably not ideal, but I think that's the issue. Oh. Okay, well, it's always blank. Right. Let's print out that exact text. Not like that. Not like that.
Vim users be like...
Probably need to round it. And also it's got 0% lightness. That's why it's always black. Well,
yeah, how did that happen?
It's like 50, right? Let's just hackily round it temporarily. Don't tell anyone. Oh, that's better. That's cool.
There we go.
Okay, so we'll call... Like, this 50 here is, like, how quickly it goes through them, right? It's all the opposite. So if we do, like, 200, it'll chill out a bit more. There we go.
That's better. I like that.
Alright. Okay, we should probably use that angle thing now, because the idea is that we have this segment, to go back to my diagram, we have this segment here, and currently they're falling like here.
Yeah.
Which is going to be a bit weird once we do the mirroring and stuff. So, let's figure that out. So, plan is, like, we could make it do a better job of this. Oh yeah, also we want to start it randomly on this line. I kind of forgot about that.
Right.
Maybe we do that first, actually.
Okay.
Let's do that. We need a method for choosing the start position. So this will be a particle. And let's just do like, we're gonna want a method. Okay. We'll start off by just returning what we had. Nope, that's not it. With y is
Hello.
divided by 2. Okay, should probably use that angle thing now, because the idea is that we have this segment. Go back to my diagram.
Ooh.
We have this segment here, and currently.
Bit of feedback there.
Yeah. Alright, so we can use that one. New particle. Where am I doing that again? Here. Particle equals a new particle. And initially we want that particle. Here we go. Let's move this. Cool. So what we want to do now is choose, I guess, a random number between here and here. Actually, way easier.
Does it
Random
need to be
angle.
Does it need to be curved like that?
I mean,
Starting positions?
I think it just makes it easier because with this way we can just choose a random like theta
Yeah.
and a random angle. And we don't have to correct for it. Like, I guess we could correct for it, but yeah. Okay. So I'm going to start by choosing a random angle, which will be up to the, we set this up before, right? Segment angle. And the distance is always going to be the same. And that distance will just be the width divided by 2. So we'll just do that. Cool. And then do some trigonometry. Okay. First try, right? Okay.
You have half an hour remaining.
Speed.
I'm kidding. You don't have to finish in an hour.
I don't think I quite got that right.
It's pretty, but
It's
not quite.
cool. It's just, yeah. Oh, wait. Same thing here. Wait, this is height plus. Alright, it's like, let's make them not move for a second. Right. I see. To be honest, this might actually be what we want, because I kind of forgot to mention before. So we actually just want to generate it in like this area, not this area, because then we'll flip it. So we'll like
Good
flip
point.
and put that here and then make 6 altogether.
Right. You're actually generating 12 segments.
Yes, yeah.
Well, you're generating 6, but turning into 12 and then putting it into a circle.
Yes. So I think this is actually correct.
Okay.
I mean, it feels like, to me, like it would be more proper to have it on the top bit. It's not really important.
I mean, if
What
it's
do you
just
reckon?
coming from the bottom half, is it still going to travel roughly always in a straight line?
I mean, I think we still just make it go left. I reckon that's the
Okay.
easiest. We could bias the movement upwards slightly, potentially.
Yeah,
I
that's what
kind
was
of just
wondering,
thinking...
like, should it go to the center or?
Yeah, the other idea I had was that we could make it so that it moves this way consistently, but its angle varies. So its angle is the Brownian motion as it gets closer.
Right.
So we could try that out. I'm kind of just intrigued to just see what happens if we
Yeah,
just
no,
allow
me
this.
too.
Yeah. So I mean, this is what we're getting. But we need to put that segment thing in. I think the noise value is quite high. If I made this quite small. Yeah, so it's just kind of where that segment was.
Mm-hmm.
It's interesting how much variance you still get, even with like no noise.
Yeah.
Okay. Particle, blah, 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 blah.
So when they hit the edge of the segment, they're just gonna like get pushed along.
Yeah, I'm just kind of thinking like we check like if they're here, go here, kind of thing.
Yeah,
So all
that
right,
makes sense.
let's correct for that. So we'll just do this movement. All right, in order to do that, we got to figure out what the angle is to them. So we'll call that angle. And am I going to get this right first time? Almost definitely not. Would it be useful to define this point, you reckon, actually? Because we do kind of use it a bit, huh?
Yeah.
Maybe let's do that.
All this trigger stuff is totally up to you.
Alright. It's getting a little bit messy. Definitely going to move this type up there. Move this down with this. Alright. Cool. Alright, I'm getting distracted. Let's define that, yeah. We'll call it like target, maybe? We'll say it's just the center of the screen. Cool, and that way over here we can do like if it's less than target.x. Lower than equal. Did we use this somewhere else, right? Yeah, here. Oh my goodness, my typing skills have gone out the window. Alright. So we want the angle now. It's like, I feel like it's clearer now what I'm doing here. So it's the y difference, and then the x difference. Cool. And then if this angle is greater than... Actually, what we'll do is we'll just clamp that angle. Is that lap? There is no clamp, is there?
No.
Sad. So it's whatever's smaller out of the angle and the segment angle, and then out of that, here we go, this one and 0. Okay. We'll call that like corrected angle. And then we just want to like, so that's kind of like taking this new angle to like this point, and then the corrected angle will be like the angle to this point over here. And so we just want to reproject to that point. So we'll say particle.x equals math.sine of corrected angle times, oh, we need that distance as well. I'm glad we made a function.
Sure.
Particle, this is gonna get upset.
Can
I knew we should have made it points.
Can you make the target a particle?
I guess we could.
I guess it needs an index.
You know what? I'm gonna do a bit of a hack. Let's say that point is a type, and it has this.
I don't think that's a hack. I think that's like the way to do it.
Yeah.
Yeah.
And we'll say, wait, I'll do it like this. Type particle equals all the fields from point and some other fields. But doesn't need these.
Yeah.
It is absolutely upsetting me. Oh no, it's fine. Cool. And then our distance just takes 2 points. And then we can define target as a point.
Nice.
Cool. And then when we call distance, it's still very up. Oh, it's because I'm halfway through writing the code. Ooh. Distance, and then the y is just that. Oh, whoops, I did sign. Alright, fingers crossed. Absolutely not. Okay, what if we don't do this? Now it's happy. What might be good, frustratingly? Wait, cos is for the x. That seems correct. Corrected angle maximum. 0 minimum angle, segment angle. Yeah, I think what might be good, Benji, is to reinstate like that setup where we had it so we could see the particle as it was moving along.
That might be good.
So let's get rid of this while loop. Actually, we can just do that. We'll get rid of this too. And we'll just draw the particle.
Well, that's not right.
I would say, yeah, not quite right. Close, though. It's not close at all. Okay, so it's doing its thing. What kind of angles are we getting? Did I do A10 2, like, absolutely wrong? Cartesian y coordinate. Target y, target x. Okay. 0. Hmm. The order of this might matter. I always get this wrong. That's kind of... It's more diverse.
It is more diverse.
Still absolutely not right.
0.5.
0.5? We would kind of expect 0 over here, right?
Wait, how are you clamping it?
With a max and then a min. If we don't correct it, what if I just do this but with the original angle? It shouldn't have any effect if I've done it right. It's not showing up. It's gone. Maybe the distance isn't right? You know what? Wait. Just do 1. Not at all. You might need to repeat that pray for you and...
Yeah. If you print out the angle.
Alright. So we get some negative values. I'm trying to think. I think that's what we'd expect, because that, like, it was here, right?
Yeah.
Wait, that's probably what the issue was when I was doing this.
Well, yeah, because you're...
Because that's going
clamping
positive.
it. Yeah.
Let's get rid of these lines again. One change I'll make that I was going to mention before. I'll get rid of this for a second. So these, like, it kind of goes here. It might make more sense to put it here so that we get positive angles.
Right.
So we'll just negate this angle. No, it's because this just needs to be minus. That was the issue. Alright, so they'll be up here now.
Okay.
That is still a negative angle. Not ideal. Alright. That actually might be what the issue was, because this might not be expecting a number system with y's going the other direction. Okay, but just with the correct distance. No. .15. That seems about right. What is it? That's like a very small, and it's like right close there. That seems correct. Okay. And then what's the distance? 150. That seems right. They both seem correct.
Okay.
Let's just only do the x. Math.cosine of the angle multiplied by the distance. The distance is going up.
Exponentially.
That's not ideal.
Sorry, not exponentially. It is going up a lot though.
Distance is still going up. So distance being overmeasured. Oh, I mean part of the issue is because I'm only doing one of those. Wait,
I would assume it's because the particle's zooming right past.
It kind of seems to be zooming right past. Times the distance. Now it should get smaller. Oh, I'm making some silly mistake, I can tell, Benji.
Yeah.
That's the wrong way. So it's the distance from the... Oh, wait a minute. Wait a minute. This is part of the issue.
Oh.
That could be part of the issue. That is a double space. Okay, alright, alright. Alright. Okay, okay. It's, I mean, it's
Beautiful.
something. Well, so just using angle, right? I feel like this doesn't actually need to be negative like that. Okay. And if we bring back this. Alright, alright. Alright.
Okay.
Like, it didn't break it. And then if we use the corrected angle. Please. It might have worked.
Oh,
It might have
I think
worked.
it worked.
Did it
I
actually
think it
work?
did.
Yes! Thank
It's
you for praying,
working.
everyone. Alright, here we go. Oh. What have I done? I see.
You know when it expects a semicolon.
What have I done? I fixed that. Uh-oh.
Uh-oh.
Oh no.
Oh,
No, oh, next problem. Oh, wait a minute. That's not ideal. Oh no. Okay, wait. I think I might know. I think this is being too harsh. Okay. Don't panic.
Oh.
Okay, but that is better. Like, it's only got... See, it's got like that one root now.
Uh-huh.
It's going down still. I'm still definitely doing that wrong. It's like going down, but it's like definitely preferring going up. Let's just increase that. Interesting.
Very interesting.
It's funny because it still tries to keep growing.
Yeah. What's going on there?
Oh, that's it's like painting out. That's the arc.
No, I see that, but like, why is it only...
Well, I mean, I never told it to stop going. You know.
No, not that. I mean,
It's like I think this should be actually plus.
it's growing down there.
That's
Oh, okay.
better. Okay, that's more like what we expected, isn't it? Alright, we're getting
Yeah.
there.
Okay.
It's gonna work.
It's like a multicolored cauliflower.
Yeah. Would not recommend eating.
No.
Yeah.
Might give that one a miss.
Yeah, I agree. Alright. Now comes the tricky... Oh, I mean, tricky... Now we've just got to flip it. Rotate it a bunch.
That's
Let's-
certainly a part.
Let's start by flipping it, I guess. It does seem to always want to grow along this edge. You seeing that?
Yeah, I am. Is the movement being biased towards going down further?
It seems like it might be. I wonder... Because I guess it's like... I'm trying to think. So it's like anyway here. Yeah, that's what it is. Because it's trying to move left.
Hmm.
It's trying to move left and it's hitting that edge and then it's just traveling along that edge.
Yeah.
Maybe the strat is, instead of doing this, we do this. We take this angle and we perturb the angle instead. Okay, times 2. Minus
Good
1.
word, perturb.
Good, yeah, that's a good word, I agree. Let's do that. And then we'll just do dis minus equals 1. Or like 0.5. Okay, that's not enough perturbation. Or it's too much. One of those. Let's try too much. Oops, wrong button. Let's try like... Okay. It's definitely interesting.
It sure is.
It's more varied, I want to say. Let's try like 2. Whoops, that's just the number 2. Here we go. Yes, okay, it was too much, I think. Because like we're working on like radians, right? Damn. So let's call this noise again and then just make noise like 0.05 or something. There we go. So
That's fun.
for the other people that aren't Benji, instead of just consistently moving left and then like randomly moving up and down, we've just got it so instead we're working with entirely polar coordinates. So from the origin, it's got an angle going out. So it's got this angle here, theta. And it's got a distance to the point. And so we just constantly march distance down while randomly changing theta. So it's kind of like wobbling like this way.
Yeah,
but it means that
like
it's
a little dude with like some hair.
Yeah.
Little lady, woman. Oh wow.
Yeah.
Beautiful.
It's symmetric
Well, I
now.
just realized your
Kinda
other
like
theta
a-
also looks like that.
Or is it dabbing? You choose. Alright. Okay.
Yeah, I think that's the strat.
This seems like the strat. Alright, let's do some flipping and stuff.
Wait, first, before you do that, I
Yes,
feel like you
yes.
should stop growing it at the edge.
You're right. Do you reckon we should just max out number of clusters? Number of particles?
Maybe like once the first particle hits the max distance.
That seems good. Yeah.
That way they'll always go out to the edge.
So like... Okay. I'm just going to change it. Say get polar coordinate. Apply brownian motion. Good to document code as I'm going. We'll call this speed, maybe. Oh no, was it 0.5? I think it was 0.5, right? Cool. They shouldn't actually really affect it too much. It'll just cause them to self-intersect if it's too high. Actually, it might be too high. Cool. To be honest, it should probably just be set to the radius. It's the wrong way around. But like halved or something. That's working. It's working well enough for now.
That looks good.
We could even, if we want like a little bit more detail, we could be doing smaller. Yeah, you can see that the speed is, what is that? Is it too slow or too high? Too slow. Interesting. It's just like very dull looking now. It's also possible my intersection code is just not working. Okay, wait, that's the opposite of what we want. Divided by 2 was the right move. Let's just go with what we had. I'm overcomplicating it. So 2.5. Excellent. Alright, let's flip them. So, we draw the cluster. This is just drawing one segment.
Wait, you haven't stopped it.
Oh, good point. We were going to do that. Sorry, I totally lost my train of thought. So, I mean, the easy... Yeah. Let's just do if one reaches a certain distance. Like,
yeah.
Stop distance equals... You know what, we'll just do it as a... down here. Like, if when it stops, we just get...
spawned from, right?
Yeah, so we just get this distance. I'm thinking like maybe like here. We could do it here, right? Because it's hit the cluster. We say like, did it hit the cluster far away? Go. We'll get this distance from the particle to the target and go if distance is greater than, what's the maximum distance? It's width divided by 2. Well, I don't know, done. It hurts the immutable programmer in my soul, but we'll go for it.
Let.
Yeah, I know, right? If not done. Cool, and it should just like stop now when it gets to the edge. Fingers crossed. Hey, that works.
Yeah.
Alright. Let's do another one. Just double check. Cool. Okay, so now when we draw the cluster, first we got to draw this one, and then we've got to do that again. So I'm thinking maybe we put this in a method, might not be a terrible idea. Draw cluster segment. So that's the same for now. So we basically want to do this. Then we want to do ctx dot scale. Ooh. Like probably like that. Then do it again. We want to save the state and then load. No, restore. So this is like store how the context is now, like the transform.
Yeah.
Draw it. Flip the canvas upside down. Draw it again. Unflip it.
Mm-hmm.
That absolutely didn't work.
Well, it did not.
It absolutely, no, it didn't. I have some thoughts about why it didn't.
Yeah.
I think it might be because from where we're drawing at. Like, it might be drawing up here, technically.
Huh?
Like, it might have, like, flipped all of the coordinates so that it would be drawing up here, theoretically. I might be wrong with that. Let's see if we do any numbers here, if that works. Like, if we do that, what happens? Yeah. So if I flip it, it's, like, outside of the canvas. So I think the fix here is we have to make it so that the middle of our canvas is here. It's just going to make everything easier, I think.
Okay.
So we'll set the target to be 0. 0. Which means it's going to draw from up here.
Mm-hmm.
That's chill.
Right, I see what you're saying now. Yeah, that makes sense.
Cool. Alright, so we can translate this to the middle.
Mm-hmm.
By half the width, half the height. Oh, it's going to continually... we got to... Oh no. Wait, the heck? ctx.save. ctx.translate. ctx.restore. Okay, cool. And then this one, now we can flip it upside down, except that needs to be a 1. Hey! Alright, nice. Alright, we're getting there. Wow, it's kind of hype. Just you like flip anything, looks way cooler.
Symmetry is beautiful.
Very nice. Alright, now we gotta spin it around. I feel like maybe I'm saving this more than I have to. Try this. And then do we want to do like... I'm just gonna use a for loop. Feels weird, but I'm gonna do it. So it's just going to draw 6 times on top of itself now. But then, before we do this, ctx dot rotate, whoops, by, divided by I, no, wait, divided by 6, times I.
Okay.
That's not quite right, is it? Divided by 3? What? It's happening!
Yo, it's a snowflake!
I mean, it looks a bit... Does it look a bit circular?
It does. Look very circular.
I mean, it's cool. I don't know if it counts as a snowflake.
I mean...
It's like when these bits here grow out more, it kind of looks like a snowflake.
Yeah. And that does seem to be happening most of the time.
Here we go. That's like snowflake-like. Snowflake-like. Maybe the colors aren't helping.
The colors do kind of make it look like something else.
We could make the colors chill out a little bit. Choose a bluish color.
Mm.
Go like, start hue equals. Let's just hack this. Okay, so of course that's not valid. I don't know what I was expecting. Alright, so we do this. Find a nice blue. That's not very blue. So it's like 219. And then we do hue rotation speed equals like... Did I do
It's definitively not
I just did 2019, didn't I? Okay, so then here we'll do this as start hue plus... Is it... hue rotation speed.
I mean, maybe the hue shouldn't change.
Maybe, yeah, maybe we change the other aspects.
Yeah.
We could move them all a little bit, maybe. I think this
Don't think
isn't
it's
working
moving.
because I'm dividing it by 200. Okay, so that's like way too fast now. But if we make this like 1, and we start it maybe a little bit lower, like we start it at like 180 and do 0.5. That's more like it.
I feel like it needs to get the other way. Like dark blue to light blue?
You actually got a great point. But we could do that. That's easy. It does go a bit green.
Does.
I feel like I'm being picky now, though.
Yeah.
Okay, wait. Little bit less, little bit less. There we go. It's a snowflake.
It is.
Okay, it's getting us to a silver green. I like it.
That's good.
I like it.
That's really good. Yeah.
Hype.
Good
All right.
time.
Hype.
All right.
We got a snowflake. I'm gonna do one final couple things. Let's just make a really big one.
For what it's worth, by the way,
Yeah.
exactly an hour.
Yeah.
since we
Honestly,
started streaming.
pretty solid. I planned
You
that.
aimed for an hour, you got it. Dead on.
Wow, it's like a Halo sword.
Snowflake at 1 hour. Yeah. Oh my goodness. Yeah. Wow.
All right.
Definitely got
Cool.
some unique snowflakes out of
Let's
this.
do proper dev stuff.
You know when all of your code is in one commit?
Implement snowflakes. Here we go. We love to see it. All right, done. Thanks for coming, everyone. Hope it was interesting to watch. Cool. I think we'll wrap it up there. I'll chuck out a link. I've created a GitHub repo for it, so it should be up
Yes.
there now. It's gonna read me. I'll make it nice so that you can like visit the site and stuff.
Mm.
It's in chat. Oh, lol, it like tagged me because I had my name in the GitHub link. Love to see it.
Yeah.
All right. Cheers, everyone.